So good morning, good afternoon, and good evening, depending on when you listen to this presentation. My name is Victor, and I'm going to be your anchor for this next module in digital forensics, preserving data during digital forensic investigation. So the question is, if we're carrying out digital forensics, how do we make sure that our data has integrity? Don't forget, in cybersecurity, we talk about the CIA. So how we ensure that we have integrity, data is not being tampered with, the data is not being affected, data, new items is not added to the content that we have, so that that evidence can be admitted in court, can be admissible. So there are a few things that we're going to be discussing in this module. Things like how do we use software write blockers? We don't want the data to be written to the hard disk, to the flash drive, to the memory card, to the storage device. How do we use both hardware and software write blockers? How do we check for hash values to be able to make sure that how we got the data after some time is still how we're going to be presenting the data. So preserving data during digital forensic investigation. Now, one of the things you want to be doing as a forensic expert is for a crime scene or for a digital evidence, you want to make sure that you preserve that evidence. The data you collect, there might be some case involving criminal case or policy violation. So how do you prove a case that this particular document has been tampered with? Or this particular document now has ABCD instead of just ABC. It then means D was added to that particular document. So you don't want people to add, to delete, to modify data. I've spoken to a lot of my colleagues, friends. Some of my students have trained in the military. When we share ideas, one shared a case study of a promotion letter, right, sent from one battalion or one location to the other. And somebody, before printing that particular notice and have it on the notice board, somebody can tamper with someone else's name. So what do they do in the forensic department? One of the things they do is to make sure that they get the hash value, compute hash value for that particular file. And before at the point of maybe receipt or the point of utilization, they want to also check the hash value and make sure that it is same. Same thing for even operating systems. When you go download operating systems, especially open source application, even yes, most of the times open source applications, like even the Linux operating system and all of the distribution, the Debian distribution, Kali Linux and the rest, you are being told the hash value of that particular file that you are downloading. The goal is so that somebody does not pick this particular operating system, tampers with it, and ships it back into the public space. People cannot take this and maybe have a backdoor within their operating system. So you are being told of the hash value from the manufacturer side or from the developer side. Once you download it from anywhere or from that same particular place, you want to just run the hash value for it. Yesterday and in the last session, we did how we can use VirusTotal to compute hash values. Yes, VirusTotal can do file integrity check. It could do manual analysis and do some basic forensic for us, and even do some footprinting for any digital asset we're trying to scan. So these are the kind of things that we want to do in order to make sure that we preserve the evidence that we have. People do not add, people do not delete, people do not modify data. The consequences are grave because the court may not accept the compromised digital evidence that you submit. So they want to make sure that you have preserved the data that you have collected. So how do we do that? Getting the hash values using software or hardware write blockers. Okay, so what's the role of write blockers? In computer forensic, preserving data integrity is very important. And the role of write blockers is just to do that, to maintain integrity. Computer forensic rule number one is to not damage your evidence, right? You don't just go about copying files because, for instance, you see a flash drive or a hard disk. If you put it into a system, most times you see that the system, in order to be able to read the file, writes to it. For instance, a hard disk that is not in a hard disk from another system, you put it into a Windows PC or a Mac PC. For a Windows PC, for instance, you see that it will first want to make you grant the host system permission. If we have time in the course of our lab, I'm going to run this particular case where you put in a hard disk or you put in a flash drive. At times, it's going to write fast to that particular flash drive or hard disk to be able to read from it. Now, that is what you want to prevent from happening. For instance, you take a Windows 8 hard disk, a system that has Windows 8. You want to image that particular hard disk. You want to copy stuff from that particular hard disk. You want to make sure that items are not written to it. That's why it's called write blockers. You don't want to write to that particular hard disk, but you actually want to read. You want to actually clone, you want to actually duplicate. So one of the ways you could do this is to use a write blocker. So it can be a soft or it can be a hard. Okay, I will show you one. So this is one hardware write blocker. This is from Tableau. Tableau does data analysis. They also have plugin tools and the rest being used by other applications, other vendors. So for instance, Guidance, they have this Tableau kit. It's for $455 on Amazon. So you just say TK8U USB forensic bridge. So what this does is that you could plug in power. Once you plug in power, you connect your device. Once you connect your device, whatever you're going to be copying from here, what happens is that data is not being written to the hard disk. There is something else that you can that can make a lot of sense to you. If you're familiar with what they call what's the word again? Okay, if I remember, I'm going to let you know. So what this guy would do is that it will prevent files from being written back to the hard disk. It will just allow you to copy out items from the hard disk. Okay, so some of the features. So it shows you backlight interface, all of these guys. It shows you the device status, the device information, the logical unit, the bridge information are easily accessible. It supports speed 1, 2, and 3. So 3 is the maximum for now. You could plug in flash drives, max storage device, any storage device from a drone, from a camera, from a laptop, from a whatever kind of means. You have a power and a USB, right? So this adapter is going to go into a female USB so that you can plug your hard disk or whatever kind of means that. So this is a hardware-based 3.0 write blocker. What other feature can I read here for you? So this is the Tableau portable family forensic bridge that supports write blocking image. Very high speed. The good thing about this is that it also computes the MD5 and SHA-1 values. If you watch the previous video before this, I demonstrated how Versata can calculate this particular sum. So instead of you, for instance, if you use FTK Imager, we're going to do that in the labs, you could pick up a file and automatically it will calculate the hash values for you. So that hash value is going to tell, if you check letter data and you get a different value, it then means that data has been tampered with. So the beauty about this particular hardware is that it computes that automatically for you. So that makes it a little bit slower compared to some software write blockers. So if you check their pricing, this is about 549. This is 455. So with shipping, you'll be spending roughly about $500-600 to get any of these write blockers. There are quite some other ones, Linux based and the rest, but they won't do as much as these premium kits. FTK Major will also be able to write block, we're able to clone. We're going to demonstrate that when we run through the labs. So hardware write blockers come in many different forms. This is one. So what you do is that this is still that same Tableau stuff. So you could connect your, this is the, what's it called? So you have different types of connectors. So this is your power. You could slave in the hard disks. This is a SATA ID. This is power SATA ID. It has a USB also. So you could plug that in. By the time you're going to be reading this data from this end, you are sure that you just be copying into the particular system or whatever. Nothing is going to be going from the system back into this hard disk. Okay, so there are some others. If you check up on Amazon, you could get one for yourself, like Webitech. They have one, I think it's a little bit cheaper, around $300 or so. Understanding hashing, I've talked about hashing, I've demonstrated hashing, so that's very clear. Hashing ensures data integrity so that there's no unintended change made to the data. When we run through the labs, we're going to do this afresh, maybe using different tools. And there are different hashing algorithms. You could check up the cryptography module in the Cisco CyberOps training on this particular channel. Check the channel, go to the Cisco CyberOps. There are about 28 modules there, about 28, 29 videos. Check for the cryptography module. Go through that module, is quite exhaustive. Talked about the different types of encryption, what is hashing, different types of hashing, which is more secured in terms of their length and the rest. So hashing is just one way for you to get an algorithm to be able to identify a particular item or particular object. So FTK Major can do is also a forensic tool. We're going to run that. This is my Linux box, Kali Linux. I just use that to get the MD5 hash value for a particular file. So if you're on Kali Linux, you just go to your terminal, you say nanodigitalforensic.txt. What you're trying to do is that you want to read this forensic file. This should be in your main directory. When you say MD5 sum digitalforensic.txt, what it does is that it computes the value. If you check this with any other MD5 utility, for instance, if you say MD5 encryption, right? So you could have MD5 encryption, MD5 decryption. So if you upload this same file, this digital forensic file I have, it's just a file with some text, you're still going to get this same value. Right? So this is it. So if I say I am training, okay, it's still loading. I'm training on digital forensics, right? So if I crypt, that is encrypt, it's going to give me a particular file. If I use this on any other stuff and decrypt, it's going to give me, it's going to go back and give me I am training on digital forensics. So so MD5 algorithm is used for encryption or fingerprint function of a file. When you say fingerprint, you're just saying you want to know about that file, you want to explore that file, you want to get a signature for that particular file. Okay, so So that's all for encryption. So the question is, okay, let me see if I can go over VirusTotal again. When we get into our Kali Linux box, we're going to do this same lab. We're going to run this with the Kali Linux box. And when we also run the FTK Imager tutorial on this same course, we're going to run through that. So just stay tuned. So this is FTK Imager. I think I have it on this system. So this is the FTK Imager. So after the slides, we're going to run this. We can also use this to compute hash value. So if I upload a particular file, let me say I upload digital forensic. Okay, let me say downloads, just the file. Okay, so checking hash. So it's trying to compute the hash value for this particular file. So once it's done, it's going to tell us what the hash value is. The question is, when we come back to check the hash value for this particular file, again, later on, the question is this same hash value? So once it's different, it then means it has been tampered with. So